Over the next few lessons, we're going to take a look at transformations of all different types of parent functions. But before we do that, I want to do a review of the transformations of the quadratic functions from grade 10. So the first example I'm going to do is f of x is equal to x minus 2 squared plus 5. Now, based on what you know about quadratics from grade 10, we can list out the transformations that are being applied to the parent function of y equals x squared. Okay, so keep in mind that this is our parent function that we're working with here. So the transformations that would be applied to that parent function would be from this 2 here that indicates a horizontal translation to the right 2 units. This plus 5 here indicates a vertical translation up 5 units. And for this function, f of x, those are the only two transformations that we have to worry about. Okay, so here's our grid. We're going to start by labeling the x and the y-axis, and then we're going to plot our parent function, which is y equals x squared. So by now we should know that 5 key points that we want to plot are 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. And because our grid has a high enough scale on the y-axis here, we could also plot 3, 9, and negative 3, 9. Okay, so there's our parent function. Okay, let's make sure we label that as the parent function, y equals x squared. Now, the function we want to look at is the parent function with a horizontal translation right 2 units and a vertical translation up 5 units. So what that means is we want to take each of the key points that was plotted on our parent function and shift them to the right 2 units and up 5 units. So I'm going to start with the vertex here. So I'm going to shift to the right 2 units and up 5 units. The vertex is now going to be at the point 2, 5. Okay. The next point, I'm going to shift again to the right 2 units and up 5. The point's going to be here. Same with this point here at 2, 4, I'm going to shift to the right 2 units and then up 5 units. There's one part of our parabola. Okay. And then this point, I'm going to shift to the right 2, up 5. And same thing with this point here, to the right 2 and up 5. Here's the other half of our parabola. Okay, again, let's make sure that we label with the equation. Okay, so there's an example to remind you of how to do horizontal translations and vertical translations. Okay, let's try another. This time we're going to do g of x is equal to 2, and then in brackets, x plus 7 squared minus 6. Again, we can tell that this equation is quadratic, and so our parent function is going to be y is equal to x squared. Okay. Now the transformations involved here, in order, this 2 indicates a vertical stretch by a factor of 2. The 7 here, now written in vertex form in brackets here would be x minus negative 7 because it's always x minus in that form. And so the h value here for the x coordinate of the vertex would be negative 7, which indicates a shift to the left 7 units. And this -6 here indicates that we're going to shift down 6 units. Okay, so here's our grid. Again, we're going to plot the parent function first. So let's make sure that that gets on there. And now, just like the last time, we're going to take each of the key points that's on the parent function and apply these transformations to it. So remember that any stretches, compressions, and reflections have to be done before you do any translations. And so we're going to start with the vertical stretch by a factor of 2. Now, this means that we're going to multiply the y values from the parent function by 2. So if I start with the point at the origin, the y value there is 0. If I multiply that by 2, I'm going to still get 0. And so that point is going to remain invariant, which means that it does not move after the transformation. The next point, 1, 1, that has a y value of 1. If I do a vertical stretch by a factor of 2, I multiply that by 2, and the new y value is 2. Next point is 2, 4. The y value is 4, multiplied by 2 is 8. Right, going in this direction, again, this y value is 1, multiplied by 2 is 2. This y value is 4, multiplied by 2 is 8. So after the vertical stretch, our parabola now looks something like this. A little bit narrower, closer to the y-axis. Okay? That's only after this first transformation here. We still have to do the shift to the left and down. Now, these two shifts we can do at the same time. So each key point we're going to take to the left 7 units and down 6. So this point at the origin is going to go to the left 7 and down 6, and the vertex is now going to be here at the point -7, -6. Right, this next key point, again, we're going to take to the left 7 units and down 6. So it ends up here. Okay, same with this point, to the left 7 units, down 6. Okay, right here. Okay, we draw in our parabola. And make sure we label with the equation. So this is g of x equal to 2 times x plus 7 squared minus 6. Okay, we'll do one more example. This one is h of x is equal to -1/3 x plus 1 squared plus 5. Okay. The same parent function, y equals x squared. Based on that parent function, we're going to have 4 different transformations here. This 1/3, so let's disregard the negative sign for now. This 1/3 indicates a vertical compression by a factor of 1/3. The negative symbol indicates a reflection over the x-axis. And the 1 indicates to the left 1. And plus 5 indicates up 5 units. Once again, we're going to make sure that we plot the parent function first, label the x and y axis, and then we're going to start on our transformations. So first we're going to start with a vertical compression by a factor of 1/3, and that means we're going to multiply each of the y values by 1/3. Okay, and so if we start with the point at the origin 0, 0, the y value is 0, we multiply by 1/3, we still get 0. The next y value for this point is 1, and so if we multiply by 1/3, we get 1/3. This y value is 4. If we multiply by 1/3, we get 4/3. or 1 1/3. The next y value, this is 9. If we multiply by 1/3, we get 9/3, or 3. Okay. So there's 1/2 of the parabola so far. On the other side, because of the symmetric properties of a parabola, the y values are going to be the same as on the right-hand side. Okay. And so that's the parabola after just the vertical compression. Next, we want to do a reflection over the x-axis. The point on the origin, because it's on the x-axis, is going to remain invariant. So again, it will not move after this transformation. But all the other points, a reflection over the x-axis indicates that the y values are going to change sign. So any y value that's positive is now going to be negative. So this, instead of being a y value of positive 1/3, it's going to be a y value of negative 1/3. This one will now be at negative 1 1/3. And this point will now be at negative 3. Okay? Similarly on the other side, again, because the parabola is symmetric. Draw in the parabola. But we're not quite done yet. We still have to do these transformations. The last two are the horizontal and vertical translations. So the shift left 1 unit and up 5 units. And we're going to take each key point and move to the left 1 and up 5. Now the vertex is going to be here at negative 1, 5. Okay, same with the next point. You have to count carefully when fractions are involved. So we'll go to the left 1 and up 5. 1, 2, 3, 4, 5. So it ends up being a y value of 4 2/3. Next one, to the left 1, up 5. Okay. And we draw in our parabola. And we make sure that we label it with the equation.